Energy. Power.
We're introducing 3 new XMR current sensor breakout boards. The first sensor is the ACT001, a TMR analog bridge sensor with an onboard current strap. Just 6 pins, input current, output voltage, and power. Each of the breakout boards has a business card size manual with key sensor specifications on one side and pinouts on the other. This sensor runs on any supply from 0 to 14 volts. We're running it on 5 volts. The output is connected to an inexpensive 2-volt panel meter. There's plenty of output without amplification, and it measures up to 500 milliamps. Let's shed some light on how it works on AC. A 40-watt bulb draws about 1/3 of an amp RMS. The meter shows a large sensor output, 115 millivolts RMS. The scope shows the sensor's AC output since it senses polarity as well as magnitude. Unlike a shunt, the sensor is isolated. Dangerous line voltage here, but the sensor output is safe. The breakout board edge connector doesn't have enough creepage for line voltage, so we snipped it off. The second sensor is the AAL024, which is a GMR sensor ideal for over-the-trace current sensing. It needs just 4 pins, 2 for the output and 2 for power. The output is linear with current, and it has a large signal compared to a shunt, 43 millivolts per amp with a 5-volt supply, the equivalent of a 43 milliohm shunt. This board handles up to 7 amps. There are also 1 amp and 50 amp versions. The drop through the shunt is about 0.08 volts at 5 amps, so the shunt resistance is just 16 milliohms. Some of that's connectors and wires, and it's with 1 ounce copper. And unlike a shunt, it's isolated. The AAL024 is GMR rather than TMR like the other 2 sensors we're demonstrating today. GMR is omnipolar, which is why we use the same color wires for both sides. We can switch the polarity and the output is still positive. So it will full wave rectify an AC current. Our last sensor is an I2C smart magnetometer over a trace. It only needs 4 pins and 2 lines of code. The sensor output tracks the current very closely over a wide range. The Trinket microprocessor reads the I2C sensor, scales the output for current, and drives the I2C display. Our smart sensors have ridiculously simple software. It takes just 2 simple lines of code to read them. Most current sensors are much more complicated. This competitive sensor has a messy pinout and complex software. Yikes. These are the 3 simple current sensing solutions we demonstrated. The ACT001 is sensitive, high temperature, and low power. The AAL024 is sensitive and has a wide linear range. The SM223 is factory calibrated, has a bipolar response, and an I2C interface. These are the ancillary components we used for these demos. Click, email, or call for more information, or to order current sensors or breakout boards. Please like this video and subscribe to our YouTube channel for updates.